Hello class, it is March 1st, first day of March. And what I'm going to do is I'm going to record this last lesson from Module 3. It's going to be lesson 19. I'm going to record the beginning portions of this. I'm going to leave the end to you guys. So in this video, we're going to go over all of the exercises leading up to exercise 7. Exercise 7, the problem set, are going to be up to you. To be honest, you guys could probably finish all, if not most of this without my help, but I feel like giving you the little bit of help that I can give before anything. So to get it started off, we're going to start with, as you can see, exercises 1 and 2. The length of a line segment is the distance between its endpoints. And, well, we've already kind of gone over this. This shouldn't really be anything too new to us. So, question 1 tells us to locate and label the points 4, 5, and 4, -3. So, before we even read the rest of this problem, let's go ahead and do that. Remember, my first number, my first coordinate is my x-coordinate, and my second coordinate is my y-coordinate. So for x, I'm going to go to the right 4 and up 5. And then for my second point, 4, -3, well, that has the exact same x-coordinate, a different y-coordinate. Now, since they have the exact same x-coordinate, I know that the line that I'm going to be drawing is going to be a vertical one. And says, well, draw the line segment between the endpoints. Well, let's do exactly that. So I am going to connect these 2 points using my straight line tool. And there we go. I have drawn this. It then asks us, how long is that line segment? Now, there's a couple of different ways that we can do this. The first way, since we have a coordinate grid, a really easy thing that we could do to find out how long this is to literally count the units. 1, 2, 3, 4, 5, 6, 7, 8. So I can just say, well, it's 8 long. I counted how long it was. But there are going to be times when we don't actually have a coordinate plane. They're just going to give you points and tell you, hey, how long would a line segment between these 2 points be? You don't have a coordinate plane to use. The best thing to do in this case is, well, I know that my x-coordinates are the same, so that means I'm going to be using my y-coordinates to find the distance. And I'm going to be using absolute value to do so. So I'm going to find the absolute value of both of my y-coordinates. Absolute value of 5, well, that's just going to be 5. The absolute value of my other number, -3, well, that's going to be 3. It's 3 units away from 0. Now, since my original y-coordinates have different signs, 5 being positive and -3 being negative, I'm going to add together my lengths, my absolute values. So, 8 is what I'm going to get because 5 plus 3 is going to give me that 8. And, well, that's the same exact thing that we got from counting. So it makes sense that we should also get 8 here. So that's our first line segment. But number 2 tells us, hey, draw a horizontal line segment starting at 4, -3. That was one of our points. That has a length of 9 units. It asks us then, well, what are the possible coordinate points at the other end of the line segment, and tells us specifically that there's going to be more than one answer. How are we going to get more than one answer for this one, though? Because if it needs to be horizontal, I can only really see one way that we can go. Going horizontal, I can go horizontal this way, but if I go horizontal this way, I'm going to be off of my graph. So clearly there's not going to be a point there, right? Well, that's where we would be incorrect. You see, just because our graph at the moment doesn't let us go far enough to the right to go 9 units, doesn't mean that there's not technically a coordinate over there. In fact, if we had changed the scale, like we've done in previous lessons, if we changed the scale of our x-axis, you would find that we would technically be able to make it all 9 units. It's just that for our current scale, we won't be able to get over there. But that doesn't mean that we can't list it as one of our possible coordinates. So if we're going 9 to the right, that means that I'm going 9 more to the right on a number line than 4 is. So, well, in order to find that, I'd just basically take my 4 and I'd add 9 to it. So, not 4 plus 9, it's 4 plus 9. So 4 plus 9, what'll that give us? That's going to give us 13. And my y-coordinate isn't going to change at all. So my x-coordinate becomes 13, but my y-coordinate stays the same. It's going to stay as -3. So one of my possible points is going to be 13, -3. For my other point, I need to go 9 to the left. And, well, going 9 to the left, well, I can only go 4 to the left until I get to 0. And then I need to go 5 more to the left from 0. And what's 5 to the left of 0? Well, that's going to be -5. -5 is 5 to the left of 0. And then once again, my y-coordinate does not change. It's going to stay as a -3. So these are the two possible coordinates. And again, since it tells us that we are looking for a horizontal line segment, we can't go up or down. That would make it a vertical line segment. So we can only go across, left or right. So it's asking us what point did we choose. The point that I'm going to choose for this one, I'm going to choose the point -5, -3. And hopefully you can understand why. Because I don't want to have to change the scale on my graph that I've already started. So the only point that fits on the graph that I've already started is going to be -5, -3. So -5, -3 is going to be right here. I'm going to plot it in a different color in order to represent, hey, we got this from a different question. And then I need to draw my line segment between them. The line segment itself is also going to be red. It's going to connect those 2 points that we have right there. And with that, that's exercises 1 and 2 done. Now what we can do is we can start to look at exercise 3, which is going to introduce us a little bit of new stuff. Exercise 3 talks about extending lengths of line segments to sides of geometric figures. Now, what exactly does that mean? We'll get into that as we go through exercise 3. It says, hey, those 2 line segments that we already drew, I have them copied right down here for the purposes of me, but yours should still be on the same page, so you don't need to worry about that. Those line segments that we have just drawn could be seen as 2 sides of a rectangle. What do we remember about rectangles? Well, it has 4 sides, 2 sets of parallel sides, and our sides, our angles are all 90 degrees. Well, we have a 90-degree angle right here. So what it's saying is that, well, we can create 2 other sides and create a rectangle from this. Given this idea, my endpoints for the first 2 line segments would be the 3 vertices of this rectangle. But a rectangle doesn't have 3 vertices, it has 4. So we're going to need to find another vertex, which is as you can see, exactly what it's asking us to do in A. It's asking us to find the coordinates of the fourth vertex of the rectangle. So there is a very simple way that we could do this. If I were to just draw a line that's parallel to this one, aka just a straight horizontal line, and then a straight vertical line from this one, I could just find where those two lines intersect, and that would be my last vertex. But what it's asking us to do is explain how we found the coordinates of the fourth vertex using absolute value. So, there's only really one way that we can do this. For our rectangle, opposite sides need to be the exact same length. So that means that whatever side is opposite of, say, this blue line needs to be the exact same length. So from here to get up to whatever point it needs to be the same length as this. Well, how long was this blue line? If we remember back to exercise 1, we found out that this blue line was 8 long. Meaning that I need to go from this point down here, I need to go and make a vertical line that goes up 8. Now, in order to go up 8, I need to talk about my absolute value of my y coordinate. So my y coordinate of this point, if we remember back, my y coordinate of this point was going to be -3. So the absolute value of -3, we already know that. It's going to be 3. We've talked about that earlier. So if my absolute value of -3 is 3, then to get back to 0, it's going to take me 3. Makes sense. And then, well, I need to find out how much more I have to go after getting to 0. So my total length of 8 minus length to get back to 0 of 3 is going to give me how much I need to continue going. So 8 minus 3 gives me 5, which means that I need to keep going up until I get to y is equal to 5. So keep going up from this point to get to y is equal to 5. That's going to be right around here. That's where y is equal to 5 is going to be. Now, we used this point to do that, but what if we decided to use this point over here? If we remember back, this point was 4, 5. 5. That sounds familiar. If we remember correctly, the point that we found here was -5, 5. Because we kept the same x value and moved up to 5. Kept the same x value when we were doing a vertical line. Now, over here, while we're doing this horizontal line, we're going to keep the same y value, and we're going to change our x value. Our x value over here is, well, it's 4. And the length of our line over here, which this line needs to be the same length, was 9. So, well, let's look at our x value and find that absolute value. The absolute value of 4, well, that's just going to be 4. So that means in order to get back to this y-axis, it's going to take us 4. It's going to take us 4 to get there. So in order to find out how much we need to keep going past that y-axis, how much we need to go past 0, I'm going to have to take 9 and subtract 4 from it. That's going to give me 5, which means that I keep going to the left 5, and that gives me my point of -5, 5. So I get the same exact point. which means that, well, that most certainly must be my point. So I'm going to draw my green lines to connect to that point, and look at that, I have found my rectangle. Now, how does this fourth vertex that we found relate to each of the consecutive vertices in either direction? Well, we actually touched on this already. For this point, we kept the exact same y value. So we took the y value from its horizontal vertex, and for this one, we kept the same x value. So for this, we can say we took the x coordinate from its vertical vertex and the y coordinate from its horizontal vertex. So we basically stole it from these other points in order to create this new one. It says to draw the remaining sides of the rectangle. Well, we kind of already did that. Now we have 3 more quick exercises to do. Exercise 4, 5, and 6. Using the vertices that we have found and the lengths of those line segments between them, it asks us to find the perimeter of this rectangle. If you remember correctly, the perimeter of a rectangle is adding together all of its side lengths. So let's remind ourselves of what each side length is, how long each side length is. Well, our original side length from exercise 1, that was 8 long. Exercise 2 told us to make a line segment that was 9 long. And, well, as we know, the opposite sides of a rectangle are going to be the exact same as whatever's opposite of it. So if this side is 9, this side has to be 9. If this side is 8, then what's opposite also has to be 8. So what we can do is we can now add these together. I've got 8 plus 9 plus 8 plus 9, or 8 plus 8 plus 9 plus 9. It's going to give us the same thing in the end. So what is 8 plus 8 plus 9 plus 9? That's going to give us, that is going to give us 34. So the perimeter of our rectangle that we've formed here has a perimeter of 34 units. I'm just going to label that as U for units. Now, it also says, hey, find the area of the rectangle. Well, the area of a rectangle is its length times its width. So our length is 9, length times height, length times width, both are the same. So 9 times 8. So 9 times 8. And 9 times 8, well, that gives me 72 units squared. 72 units squared. Because 9 times 8 gives me 72. Exercise 6, however, is a little interesting. It says, hey, let's draw a diagonal line segment through the rectangle with opposite vertices for endpoints. So what I'm going to do is I'm going to do exactly that. It only tells us to do one line segment. I actually meant for you to be a different color, so let's swap over to this purple. Draw that vertical line, this not vertical line, this diagonal line. What geometric figures are formed by this line segment? Well, just looking at that, I can tell you exactly what that shape is. There's two of them. They're both triangles. Both are triangles. It then asks us, well, what are the areas of these figures? Now, well, I could do this in a couple of different ways, but instead of just pulling out the formula for what a triangle is, I can actually just look at my shape. If I look at it, honestly, to me, it looks like it's just cut in half. It's just taking the area of my rectangle and cutting it into two equal-sized pieces. So what I can just do is I can take my 72 and I can just divide it by 2. I can split it in half. So by doing that, I'm going to get 36 units squared. And I'm going to tell you right now, that's honestly exactly what I would do if I was using the formula, because the area of a triangle is 1/2 base times height. So that would be 1/2 times 9 times 8. And oh, look at that. We already know that 9 times 8 is 72. And then 72 times 1/2 is the same as dividing 72 by 2. We get to the same answer no matter what. Now, as I said at the beginning of this video, it is now your responsibility to finish that last exercise as well as the problem set. I have given you a few coordinate planes to help sort of go through your work for the problem set, because the problem set doesn't actually give you any coordinate planes to work with. So I thought I would give you the extra coordinate planes just in case you need them to do your work. But with that, that's going to become the end of our video. I am going to see you guys tomorrow where we'll work on a little bit of review. And then I'll probably give you your review packets for Wednesday and Thursday to work on so that we can get ready to take this test. With that, I hope you guys all have yourselves a great day. I will see you all come tomorrow. Farewell.